I'm Seema and welcome to part 5 of the chapter Hydrocarbons. We were doing nomenclature of alkanes. Moving ahead with that, in this video I'm going to solve two solved examples, explain them just to make nomenclature a little more clearer before we go to reverse nomenclature in the next video. So this is question 13.2 of your textbook. The question reads, write structures of different isomeric alkyl groups or alkyl groups corresponding to the molecular formula C5H11. Write the IUPAC names of the alcohols obtained by the attachment of OH groups at different carbons of the chain. So we'll first write all the isomers of the pentyl group, that is C5H11, and after that, whenever we have that empty space of, the general formula for an alkyl group is CnH2n plus 1. So it has one electron or one bond less than the corresponding alkane. So it has that one empty site. At that empty site is where we will be joining the OH group and getting the different types of alcohols, and we'll be naming those also. So let us start writing the different possible isomers of the alkyl group. And once we do that, I'm going to put the OH everywhere and then we'll name it. So the first one, it would be the straight chain. Since it is 5 carbons, it will be CH3, CH2, 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 CH2. Okay, 1, 2, 3, 4, 5 carbons, and there is an empty end here, right? The second would be that let us take this empty end to different places. So this will be the 2 carbons on the ends will have CH3, and the empty carbon, 1 hydrogen less, will be on one of these 3 carbons. So you'll have CH3, let me give a little more distance so you have enough space to write. CH3, CH2, CH2, CH, and CH3. So now the empty end is on this carbon. In the third isomer, let us make the empty end on this carbon. So let's write, it'll be CH3, straight chain again, CH2, CH, empty end comes here, this becomes CH2 and CH3. If you count the number of carbons and hydrogens in each of these isomers, it will be the same. They'll all be C5H11. So this empty end now, the bond with carbon here is the third carbon. So it is, in this case, it was the first carbon which had one empty end. Here it is the second carbon, here it is the third carbon. Now, can the next isomer be where I have this carbon having the empty end? I can make it, but it will be the same isomer as this. It will only be that you're looking at it, I'll have to start counting according to the lowest locant rule. If I put the dash here, that is, if I leave the empty bond here, then I'll have to count from this side, so it will be nothing but the same. Therefore, out of all the straight chain isomers, we get these 3 options are the ones that we have. Now, the next would be, let us come into, use this end here and have one of the methyl groups as a branch. So let's have the butane to be the parent chain, and let's have the methyl group somewhere else. So you'll have 4 CH3, CH, CH, CH. This is the end which is free, and 4 carbons, so I'll put a methyl group here, CH3. So this becomes CH and this becomes CH2. Okay, one option is this. The next can be that the methyl group is here on the third carbon. If we say the OH is here, the empty end is here, the unsaturation in a way is here, then the methyl group is to the next carbon, and now in the next isomer this methyl group will be on the next carbon. So you'll have CH3, CH, the CH3 comes here, this becomes CH2 and this becomes CH, and the empty end is here. Now, is there a possibility of another isomer? Yes, there is a possibility. You can still have another branch. So if we have another branch, then we'll have CH3, C, a CH3 here, a CH3 here, and this becomes CH and the free end. You still have 5 carbons? Yes, you still have 5 carbons and 1 hydrogen. This would be, sorry, it will be CH2, CH2, and the free end, right? So, because being the terminal carbon, it should be CH. Oh, I made the same mistake all over. This should be a CH2 also. So, now carbon here is forming 1, 2, 3, 4. The third bond, the fourth bond should be with the OH that we'll be making later. Because we are making one bond less, which we are showing by this dangling bond. Now after these, now how many do we get? 1, 2, 3, 4, 5, 6. These are isomers where in all the cases we have assumed that the OH group which is going to come is kind of except for these linear ones, the OH was here in the end, and in these two it was at a different position. But in these branched chain isomers, we have till now assumed that the OH is on the end or is on the terminal carbon. Let us change the position of OH now. If I change the position of OH from this carbon to this carbon, it would be the same isomer because this isomer is symmetrical. If I have this OH on this carbon or any of the 4 carbons here, it will be the same thing. Therefore, this one will not have any more isomers. But look at this. Can I change the position of OH for this one? Of course I can. And how can I do it? Now, these two, these two, I can either have this OH here or I could have the OH on the same carbon. Let's do that. CH3, CH, the CH3 I'm writing up here, and the OH dangling end here. So this would not be CH, it will become C, since you have to remove 1 hydrogen for every bond that you make. And this one now becomes, the next one becomes CH2, and this becomes CH3. So now we have the OH also here at this carbon. And in the next we can have the OH here. So CH3, CH, CH3, this also becomes CH. Let me write the CH3 down here to give you space to write down the name. CH3, this becomes the dangling end. So now 1, 2, 3, 4, yeah. And this is CH3. Now tell me, is it possible to move this bond here and would it make a change? If I move this bond here, I get the same structure. So these are the maximum number of isomers, or let us say that here I did the branching, I put both of them here. If I put both of them here, what difference would it make? Let us say that if in this one, if I did CH3, C, H2, C, CH3, dangling end, CH3. Let us say I did it on this one. Then it would be the same structure. Do you see? I would CH3, CH2, C, CH3, dangling end, CH3. It would be the same molecule, so it's not an isomer. This is the maximum number of isomers that I can make of the propyl group. Pentyl group. Now, let us put the alcoholic group at all the dangling ends and then we'll name the compounds. Here you have OH here, okay? Here you have OH here. Here we have OH here. Here we have OH here. And here we have OH here. All dangling ends, I'm putting the OH there. Right? Now let us name the compounds. This is pentanol. When the substituent is at the first carbon, there is no need of writing a locant. So there are 5 carbons, so it is pent. It is saturated, so it is N. There is an alcoholic group, so it ends in all. It is pentanol. This one is 2 or pentan, pent, and 2 all. The all is at the second carbon. This would be pentane 3-all or 3-pentanol. The way we used to write it earlier used to be writing 2-pentanol, 3-pentanol is how we used to write it. But these days we write the locant right in front of the name, that part which represents the functional group, to specify that the all is at the second position, the all is at the third position. Now this is butanol. Do you see? This is the parent hydrocarbon, this is the alcoholic group, and the methyl group is a substituent. So this becomes butanol, and the all we will try to give the lowest locant to the functional group. So OH will get the lower number. Always the counting will be from that direction where OH gets the lower locant. So OH gets the lower locant if I start counting from this direction. So this becomes, this is the first carbon, this is the second carbon. On the second carbon, you have 2-methyl butanol. There are 4 carbons now. Butanol. Okay. So how would you name this compound now? This has got the all is on the first carbon and the methyl is on the third carbon. 1, 2, 3. So I'll write it is 3-methyl butanol. Right? This one would be 2,2-dimethyl 2, 2 hyphen dimethyl 2,2-dimethyl propanol, because here the parent hydrocarbon becomes this and these two become branches, right? Here you will have, this is butanol because the main chain has 4 carbons and it has 2 substituents, the alcoholic group and the methyl group on the same carbon. So we'll count from this direction to get the lower locants on for both of them. So according to lowest locant, sum of locants rule, you count from this direction 1, 2, 3, 4. So it is butanol, and on the second carbon you have methyl and alcohol. So alcohol is written as a suffix. So as the prefix we are going to write the methyl. So we'll write 2-methyl butane 2-all. Do you get it? The all is also on the second carbon. Therefore, this locant tells you that the all is on the second carbon, and this locant tells you that the methyl group is on the second carbon. For this compound now, this is the all. You'll start counting from this direction so that the all gets the lower locant. So this is again butanol, but with methyl. So, but it is butane 2-all. So you'll say it is 3-methyl butane 2-all. Right? So these are the different compounds, the different isomers and the different alcohols that you will be able to prepare. I just noticed in the textbook that the locant 1 for the alls has been given throughout in this example in the NCERT textbook. The locant 1 has been used, that it is pentane 1-all, like this is written as pentane 1-all. The locant 1 has also been written, although if you ignore it, no one is going to deduct marks for that. 1 is understood. Alright? And now we'll do question 13.3. Give me a moment. Now this is question 13.3. You have to write the IUPAC names, 3 IUPAC names, and these 3 molecules have been given to you. The molecules on purpose have been written as condensed formulae, and whenever you get such condensed formulae, you are expected to expand them, because once you expand them and then give the IUPAC nomenclature, it becomes much easier rather than trying to really, understand it this way. So let us expand the first molecule here. The first molecule would be, there is a carbon with 3 methyl groups. So let us write the methyl group here. This is the carbon. It has got 3 methyl groups. So let me write these 3 here like this. Then there's a CH2. Then there is a carbon with 3 methyl groups again. So one methyl group is here, one is here, and one is here. Do you see? As soon as you expand it, it appears to be a much simpler compound actually. So now you have to give the IUPAC name. Choose this as the parent chain. Okay, this is your parent chain, the straight chain, longest chain rule. These 4 are substituents. These methyl groups, which appear to be methyl groups, are actually a part of the chain. Whatever you have on the end has to be the tree growing taller from both roots and the head, that is the tip. So these are not branches, the branches are only these 4. So how would you name this? It is a very symmetrical molecule. There are 5 carbons. If I count from this side, my locants will be 2, 2, 4, 4. If I count from this side also, my locants will be 2, 2, 4, 4. So it doesn't matter which direction I count from. This molecule is a pentane, 1, 2, 3, 4, 5. So it's a pentane. And there are 4 methyl groups. So you'll say 2, 2, 4, 4, tetra methyl pentane will be the name of this compound. 2,2,4,4 tetramethyl pentane. The second compound now, let us expand this also. CH3 whole twice C. And then there's a C, no, a bracket, C2H5 whole twice, yes. So let us write the C here, this C, the central carbon. This is a bracket, I just made it a little smaller so it's a little confusing for me itself. Okay, so the carbon I write, and I write the two methyl groups. So I write one methyl group here and one I can write as a branch. Okay, and this now has 2 ethyl groups. So I write C2H5 here and I write a C2H5 here. Do you see? So I have C2H5, C2H5, and if I had to expand the C2H5, how would I write it? It would be CH2, CH3. And if I expanded this, this would also be CH2, CH3. Now, when I'm naming it according to the longest chain of carbons that I have to choose, this will become CH3, CH2, C, CH2, CH3. This becomes the longest chain and not this one. So the methyl groups, if you really look, are only shortening the chain. This, if I had instead written, it doesn't make a difference. Carbon makes 4 bonds. Whether I write this ethyl group here or here doesn't make a difference. So let me write it here instead, because that will make my chain, it will make clear to me CH2, CH3, and this becomes CH3. Now look, it appears to be so simple. After expanding the formula, the naming becomes so much easier. It becomes clear to you which is now the longest chain. 1, 2, 3, 4, 5. It has 5 carbons. And there are 2 methyl groups. There are only 2 branches which are methyl groups. So I will name it as pentane, and the methyl groups are on the 3rd carbon. So we'll write 3,3-dimethyl pentane. That will be the name. Alright, so now let us do this. The compound is tetra-tertiary tetra-tert-butyl methane. How interesting. The parent hydrocarbon, according to him, is methane. It has only 1 carbon. And the groups that are attached are so bulky. There are 4 groups, and the 4 groups are tertiary butyl groups. What's a tertiary butyl group? If this is a carbon, it is attached to 3 other carbons. CH3, CH3, CH3. That's a tertiary butyl group. And since the parent is methane, this is the carbon, and it is attached to 4 such tetra tertiary butyl. So 4 butyl groups. So C, CH3, 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 C, CH3, 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 C, CH3, CH3, and CH3. So it's tetra, there are 4 tertiary butyl groups, and the parent according to him is methane. look at the expanded structure. It's not methane. The parent hydrocarbon can be either, there can be two chains. Either this one, 1, 2, 3, 4, 5 carbons, or it can be this one, 1, 2, 3, 4, 5 carbons. Do you see? You can have the parent chain, the longest chain would be a 5 carbon chain. So why will I choose the vertical one? I'll choose the horizontal one. This is my parent hydrocarbon. It is not the methane as given in the common name. So if this is my parent hydrocarbon, what are the branches that I have? I have methyl here, methyl here, methyl here, and methyl here. 4 methyl branches and 2 tertiary butyl branches. So I have methyl and tertiary butyl branches. And my parent is pentane. Now about the locants. If I count from this side, I get 2, 2, 4, 4 for methyl groups and 3, 3 for the tertiary butyl group. Even if I count from this direction, I get 2, 2, 4, 4 for the methyl groups and 3, 3 for the tertiary butyl group. So that is understood. I'll get the same locants either, so I can count from any direction. So whenever you have a choice, you would like to go from left to right because that's the direction in which we write. So it's easier for us. Then, when we are naming the compound, we have to keep in mind when you have different substituents or branches, you have to name those substituents according to their alphabetical order. Even if the numbering is done in whatever, the locants are assigned in whatever way, it is the alphabetical order in which you have to write it. When you have a hyphen in between like di, tri, and whenever there's a hyphen, that's not one word. And therefore, this is not considered as in the alphabetical order. The T is not considered. Rather, the group, the B of the butyl group will be considered. And here you have methyl. So which comes first in the alphabets. B comes before M. So we have to write the tertiary butyl group first. So how many tertiary butyl groups do we have? 2. And what is the locant for them? The third position. So we'll say 3, 3. Right? 3, 3. Di, hyphen again, tertiary, tert butyl, tert butyl, then you have 2, 2, 4, 4, tetra methyl, pentane. 2244 tetramethyl-pentane will be the name of the compound. Right? 2244 tetramethyl-pentane. So this was the naming of these hydrocarbons. And with this, I'll wrap up today's video. After this, I'm going to do the reverse nomenclature where we'll be writing down the name from the formula. And then I'll solve one or two more solved examples before moving ahead to the next topic. So with this, I'll wrap up today's video. If you found it helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching. Bye-bye for now.